Okay, let us move on and try to find okay, this is my problem. Okay, is this okay? This is going on. So what I have is, okay, let us try to find the second equation and its small signal model. Second circuit, what I have is, so I have a resistor RD, and then I have a diode connected MOSFET, that is drain is connected with short, and this is VDD is equal to 1.8 volt, RD is equal to 5 kilo ohm, this is M1, and W by L is 20 divided by 0.18, and lambda is equal to 0.1 volt inverse. These are the values that I have. Let me keep so fine. These are the values that I have. So I was asked, of course we are asked to find what is the small signal model of this. So let me rewrite. This is a gate, source, this is plus minus VGS. Since gate, this is drain, between drain and source we have GM into VGS as the current source. This is R0, and of course we will be simply replacing this by its AC small signal model, means okay, this is grounded. So then you will be connecting a RD between drain and AC ground, drain and AC ground. So this is the equation I have. This is the equation. This is a circuit diagram. How about this gate is shorted with this? So let me short this gate with this drain. So this is the circuit, and this is source, which is now grounded. So we are asked to find what is R0 and GM. So for which I should know the value of ID, which is nothing but half Kp W by L VGS minus VTO whole square into 1 plus lambda into VDS. But in this case both VDS is equal to VGS, because this gate and drain is shorted here, so that I can write VGS is equal to VDS is equal to VDD minus IDRD. So in this expression I will write ID is equal to half Kp W by L. It is VGS is VDD minus ID RD minus 0.4 whole square multiplied by 1 plus lambda into VDS is again VDD minus ID into RD. So in this we know everything except ID, so we can find the value of ID here. So now it is alpha A, alpha equals 100. Okay, of course by this time you're all comfortable with this. 100 exponential minus 6 into W bell is 20 divided by 0.18, close the parenthesis, multiplied by 1.8 minus alpha A into RD is 5 exponential 3 minus 0.4, close the parenthesis, square of that, multiplied by 1 plus 0.1 into, open the parenthesis, 1.8 minus alpha A into 5 exponential 3, close, shift cal. Actually this has got two values of ID. So one of the values 2.356 milliamperes, the other value equals -1 equals shift cal. The other value is, let us see how much is the value. So one is 2 point this and other one is suppose if I say engineering, it is 250.74 microampere. So let us find out of these two which current is correct, because if 2.35 milliamperes flows through this, so it is 2.53 multiplied by 5, so that will be 12.65 volts. So that will be 12.65, which is ID into RD, which will make your MOSFET to that's not possible. So this is not a possible ID, so this is a possible ID. So if this is ID, I can find what is R0. So what is R0? It is 1 over ID into lambda. So ID is 250 micro. It is now 250.74 exponential minus 6 into 0.1 whole inverse is, let me just press this in G, it is 39.88 kilo ohm is the value of R0. GM is under root of 2 IV Kp into W by L. Let me show. Okay, now under root of 2 into 250.74 exponential minus 6 into Kp is 200 exponential minus 6 into W by L is 20 divided by 0.18 close. So it is now 3.33 millisiemens. So this is how you can write the small signal model of this MOSFET and the corresponding GM R0 values. RD is known as 5K. So this is 5 kilo. Again, you can see here we found two values because ID is a part of that quadratic term. Wherever a unknown parameter comes as a quadratic term, you will certainly have two values. So out of which you have to discard one with some proof. So if you take this value of ID, the VDS comes out to be negative, which is not a possible answer. Okay, let us go to next problem. The next problem is this. Okay, you have a current source of 1 milliampere, so that our life becomes very easy here. So why it becomes easy? Because your ID is already given, directly given. Okay, let us do this problem. So there is a current source with 1 milliampere, and I have this as this is M1, this is VDB. Okay, whenever we write the small signal model, okay, let me show this. One important thing is that when we write the small signal model, all DC will be replaced by a short circuit, whereas this DC current source will be represented by open circuit. So now this is how you have a short here. This is now open circuited, and you have this is your MOSFET. This is M1. So what is the small signal model of this? Small signal model is hardly this. So this is R0 GM into VGS, and this is shorted here. This is gate, drain, source is grounded. So since ID is 1 milliampere, we can find what is R0 is. R0 is 1 over ID into lambda, which happens to be 10 kilo ohm. Of course, 1 over 0.1 milli is 10 kilo ohm. How about GM? GM is equal to under root of 2 ID Kp into W by L. So everything is known. You can try and it's actually 2 exponential minus 3 into 200 exponential minus 6 into 20 divided by 0.18. Close, one close or two close? I think it's only one close. So it is 6.66 millisiemens. So this is the value of GM. So R0 is 10K, GM is so and so. So there is no RD given here. So this is the small signal mode of this circuit. So this is plus minus VGS. It is as simple as this. And let us move on to this. So we have this circuit. Now it's interesting to see that. So we have this is connected there, and I have a 2K resistor connected between source and ground. This is 1.8 volt. Fine. So we are again asked to find the small signal. We are asked to construct the small signal model. Let us construct the small signal model. So the immediate construction is, this is AC grounded, so this will also be AC grounded because these are shorted, and you have this is ground, this is 2K, so this is 2K and this is M1. So now what is the small signal model? Small signal model is as simple as this. This is GM into VGS, and I have a resistor between drain and source, which is R0, and this is grounded. This is also grounded because you can see drain and gate are grounded. Then I have a resistor connected from here to ground. This is RS. But we have to find the value of R0 and GM. So what is ID? ID is equal to half Kp W by L VGS minus VTO whole square into 1 plus lambda VDS. So VDS is again VDD minus ID into RD. Okay, ID into RS. This is RS. ID into RS. So do we know everything except ID here? I know this, I know this, I know this, I know this also. What is VGS now? VGS is VDD minus ID into RS. So VGS, okay, you can further write it as ID is equal to half Kp W by L VDD minus ID into RS minus 0.4 whole square multiplied by 1 plus lambda 1.8 is 1.8 minus ID, that is ID into RS. RS is 2 kilo. This close, correct? Lambda into VDD minus ID into RD. So let us try to find what is ID now. So it is, okay, let me find it here. Let me go back around. So it is alpha A, alpha equals 100 exponential minus 6 exponential minus 6 into 20 divided by 0.18 multiplied by 1.8 minus alpha A into 2 exponential 3 minus 0.4 whole square multiplied by 1 plus 0.1 into, open the parenthesis, 1.8 minus alpha A into 2 exponential 3 close, shift cal. So I'll get again two values of ID. So one of the value of ID is, so if you actually press engineering, it is 588 microampere. It is 588.36 microampere. The other value is, let me make it equals 1 equals shift cal. Okay, let us, okay, this is 5.87 milliampere. So you have two currents, one is 588 microampere, other one is 5.87 milliampere. So now we need to discard one of them. Which one to discard? If you can see, if 5.81 milliampere flows to this, then the drop is how much? Drop is 10 volt or 11 volt something, so which is not possible. So that's why we are discarding this value. So we consider only this value. So this 5.87 is discarded. If this is the value of ID, you can find what is R0. So how much is R0? So R0 is 0.1 into 588.36 exponential minus 6 equals whole inverse is this. So it's actually 16.99 kilo ohm is the value of RD. 16.99 kilo ohm, almost 17 kilo ohm. What is GM? GM is again under root of, you can use this same equation, but the values will differ. So it is now under root of, okay, under root of, open the parenthesis, 2 into 588.36 exponential minus 6 into 2 ID into Kp is 200 exponential minus 6 into W value is 20 by 0.18. So that's the W bell constant given. Close. Okay, the GM value is 5.11 millisiemens. This is the value of RD in GM. Okay, this is R0 almost 17 kilo ohm, GM is 5.11 millisiemens. So this is the circuit. What here? This is grounded, this is grounded. Because no need to show this again because this is already grounded on either side. Let us see the next problem. Okay, this is also straightforward. So now you have drain and gate shorted and you have a 0.5 milliampere current source, which is, okay, let me write that. This is VDD and I have 0.5 milliampere current source. It is as simple as that. So this is gate, drain, source. You have an open circuited current source. This is open circuited and this is GM into VGS. This is shorted with drain and drain is grounded and I have a R0. This is R0 and this is plus minus VGS. So what is R0 is equal to? R0 is equal to 1 over ID into lambda. Since ID is 0.5 milliampere, I think R0 comes out to be 20k. So what is now R0? It is 0.5 exponential minus 3 into 0.1. Whole inverse is, as I said, 20 kilo ohm. This is 20 kilo ohm. How about GM? It is under root of 2 ID Kp into W by L. So ID is 0.5 under root of 2 into 0.5 exponential minus 3 into 200 exponential minus 6 into 20 divided by 0.18 close. It is now 4.71 millisiemens. So this is how you can find the small signal model of various circuits. That's it. Okay, we will do remaining problems in the next video.